Calculating the 10th Dedekind number in a probabilistic way. What are Dedekind numbers? It is a number of monotone Boolean functions of n variables, where n can be 0, 1, 2, and so on. What is Boolean function? A Boolean function is a function of when variables, which are Boolean, and return type is also Boolean. Boolean means that can be true or false, often represented by 1 and 0 in computations. How many Boolean functions are there? Having 0 inputs, there are 2. Constants true and false. Having 1 input, 4. Constants true and false, x and not x. Having n inputs, 2 to the power 2 to the power of n. This number grows very fast. What are monotone Boolean functions? A Boolean function of n variables, f of x1, x2, x3, and so on xn, is monotone if changing any input from 0 to 1 will make a function value not change or change from 0 to 1. For such function with 2 to the power n possible input values, and for each input value it has an output value, if we write all outputs in a string, say 0, 0, 0, 1, this string can be represented as integer value of 2 to the power n bits. Standard unsigned int C type represents 32 bits, can hold value of 5-variable Boolean function. Finding number of monotone Boolean functions of n variables. It is possible to check if given Boolean function is monotone or not, and looping through all Boolean functions, checking them, counting, will give the answer how many of them. This process is very inefficient. A monotone Boolean function of n variables can be constructed instead from pair of monotone Boolean functions of n-1 variables, provided the first function gives smaller or equal values compared to the second. If list of monotone Boolean functions stored in computer memory in compact unsigned integer form, the comparison of two functions is a simple binary operation often done in one computer cycle. Looping through all pairs of monotone Boolean functions of n-1 variables will give list of monotone Boolean functions of n variables, and size of this list is nth Dedekind number. A new function f can be stored in a memory as a concatenation of two unsigned integer form inputs from the first and the second function. Making lists. Starting from n equals 0, we get two functions represented by constants 0 and 1. For n equal 1, we get 3 functions. For n equal 2, we have 6, and so on. Number goes up very quickly. For n equals 6, we have more than 7 million functions, each taking 64 bits of space. For n equals 7, this number is 2.4, 10 to the power 12, and it's too big to fit into computer memory, yet we can compute this number from values for n equals 6 without storing values into memory. N equals 8, 9, and 10. Several tricks were made to compute Dedekind numbers 8 and 9. See such a huge values, and Dedekind number 10 has not been calculated yet. Probabilistic calculations. We can compute approximate value for some mathematical constant by using probabilities. If we drop many points inside a square and count how many go inside circle, we can calculate number pi is 4 times p. Circle has radius 2, square surface area is 2 by 2 equal 4, circle area is pi, where probability p of point falling inside the circle is a ratio between surface areas of circle and the square. Probabilistic calculation of Dedekind number 10 by pairs. We start by generating a list of monotone Boolean function of 6 variables. It has 7.8 million 64-bit records and it fits into computer memory. From that list, we can take two random functions and check if function 1 is less or equal to function 2. If so, we have generated a random monotone Boolean function of 7 variables. Repeating the process, we generate a stream of such functions. In similar manner, we generate a stream of monotone Boolean functions of 8 variables and so monotone Boolean functions of 9 variables. By making two random monotone Boolean function 9 pairs, we calculate probability P that f1 is less or equal to f2 for such pairs. Using this probability, we calculate Dedekind number 10 as P times Dedekind number 9 squared. Results of the calculations. The median value of D10 is 8.92 by 10 to the power 278. Standard deviation 2.3, 10 to the power 76. Standard deviation is 0.3% of the value. Compute time is 95 days of M1 MacBook Pro. Source code available on GitHub.